you say?
Hit the road, Jack, and don't you come back no more, no more, no more, no more. Hit the road, Jack, and don't you come back no more.
Oh woman, don't treat me so mean. You're the meanest old woman that I've ever seen. I guess if you say so, I'll have to pack my things and go.
That's right, hit the road, Jack, and don't you come back no more, no more, no more, no more. Hit the road, Jack, and don't you come back no more.
What you say?
Hit the road, Jack.
Here we go, 6.3 mole conversion video. Let's talk a little bit about what we've done up to this point. So far, we learned what a mole is. A mole is very similar to something like a dozen. Okay, whereas I say the term dozen, you think of 12. From now on, when I say the word mole, or 1 mole, you should think of 6.02 or 22 times 10 to the 23rd. Because this is what it's equal to. Now, the units here, usually when we talk about dozens, it's like equal to 12 eggs, maybe. Okay? For this, you can say atoms or molecules. I'm just going to use the term particles for now. And, if you remember, this is equal to this number, which is known as Avogadro's number. Now, I apologize, I think in the last video I misspelled his name. How dare I? So this is Avogadro's number. So we learned that in the last video. We also learned about this term called molar mass. And that when you have 1 mole of any substance, it's equal to the molar, of any pure substance, it's equal to the molar mass of that substance. And what I mean by that, if you have a mole of calcium, it's equal to that mass in the periodic table of calcium. If you have a mole of a compound, you just take the elements, if you remember, and add up their masses, and that's the molar mass of the compound. So, one last thing we learned about how to do a one-step conversion in a Flim chart, how to go from moles to particles, or mass to moles. Today, we're going to do a two-step conversion, so pay attention. There are 4 problems I'm going to do on here. If you're getting this right away, there's no reason to really go through the whole video, but if you're not, I'm doing 4 practice problems on here to help you out. So here we go. Alright, if you have 3.22 times 10 to the 25th atoms of calcium, how many grams of calcium do you have? So we start off with 3.22 times 10 to the 25th atoms of calcium. We're going to put it in our Flim chart here. That's our given. Alright, now just like the last Flim chart, I don't want to keep atoms, so I'm going to put atoms down here because I want it to cancel. So my atoms of calcium is going to go down there. Alright, the difference now is we don't know a conversion factor that goes here, how to go from atoms to grams in one step. However, we did learn in the last video how to go from atoms to moles of calcium. We can do that in one step. But we want ultimately to get to grams, so this is where the two-step Flim chart comes in. I don't want moles of calcium, so just like here, when I didn't want atoms, I'm now going to put moles of calcium down bottom. And now, from the last one, we know how to go from moles to grams. So here's our 2 steps. Alright, if you remember, 1 mole is equal to 6.02 times 10 to the 23rd atoms in this case. And if you also remember 1 mole is equal to the molar mass. Alright? And so, here we go. Mole and atom together. My mole is 1. My atom is equal to 6.02 times 10 to the 23rd. Over here, I got moles and grams together. My mole is 1. My grams is the molar mass, and it's from the periodic table. We're talking about calcium here, so I look over here, boom, there's calcium right there. It is 40.1 grams if you use your periodic table. So 40.1 grams. We will now plug this into our calculator. I'm going to try to pop up a calculator on my screen here, so give me a sec. And there it goes. And so here we go. I'm going to plug into my calculator to see how you plug it in. So I started off with 3.22. Alright. Now, instead of doing times 10 to the 25th here, I'm going to do this little button here. It pops up as an E. On a graphing calculator, it's second to comma. Some things you might have to search around to find your E. Other calculators, it might be a little different. All right, I'm going to come back and show you, if you're not going to use this, I'm going to show you how to properly put this into your calculator if you're going to do the times 10 in just seconds. So here we go. So E to the 25th. All right, now you can put multiply by 1, but that's the same number. So multiply by 1. All right, then divide by 6.0. Oops, missed my point there. 6.02 E to the 23rd. I'm going to press enter. Okay, so I did that step here. Now I'm going to multiply times 40.1 and press enter. And then you can divide by 1, and that's great. Alright, if you are going to use the times 10, here's what you must do. Alright, when scientific notation, you have to put this in parentheses. You have to do it. So if you're not going to use this little E button, that's fine, but here's what you need to do. You need to do parentheses 3.22 times 10 to the 23rd, close your parentheses, divided, or you can multiply by 1 if you really want to, but then divided by parentheses 6.02 times 10 to the 23rd, close parentheses, press enter, and then multiply by 40.1. That's not a 1. Let's try one more time. Boom, there it is. Alright, and something did not like us there. Oh, I see what I did. Let's try to put this back in here. 3.22. If you look up here, I did to the 23rd. Sorry. Times 10 to the 25th divided by parentheses 6.02 times 10 to the 23rd. That's much better. Now multiply times 40.1. Boom, and there's your answer from earlier. Alright, so our answers for CP, for my college prep classes, just do it to 2 decimal places every time. So 2,144.88. Okay, 2,144.88 will be our answer. I ran out of room here, so I'm going to write it over here. 2,144.88. Let's look at my units. Atoms cancel out. Moles cancel out. I'm left with grams of calcium. Now, if you were in my honors classes, CP, just don't listen to this for just a second. If you're in my honors classes, you must do sig figs. This has 3 sig figs. This has 3. These ones are infinite sig figs because it's exactly 1. This has 3. So our answer can only have 3. So your answer in honors will be 2,140 grams of calcium. Okay? Alright, everybody back with me. Let's go to the next problem. Particles to mass. Okay, we start off with 4.62 times 10 to the 22nd molecules. Please write out the word molecules. Don't write out MOL, that stands for mole, okay? So you must write out the whole word molecule. Molecules of carbon dioxide. Alright, once again, I want to cancel out what I'm given, my molecules of CO2. I want to go to grams, but I can't do it in one step. However, we know how to go to moles of CO2. And then from there, I'm going to cancel out my mole of CO2. And we're going to go to grams of CO2. So if you remember, 1 mole is equal to 6.02 times 10 to the 23rd molecules. And then 1 mole is equal to, I don't know what that thing is, equal to molar mass. So 1 mole, 1 so it's the number mole, is equal to 6.02 times 10 to the 23rd. Avogadro's number there. 1 mole down here is equal to molar mass. Let's look, except this time we have a compound, 2 elements together. So hopefully you remember from last time. Let's find carbon first. It's right here, 12.0. So for carbon, we got 12.0 grams. And how many carbons are here? There's 1. Okay? So we can just leave that there. For oxygen, molar mass is 16.0 grams. But for oxygen, we have 2 excuse me, oxygens in the formula. So remember, we got to multiply by 2. We get 32.0 grams. And the other one was 12 grams. So we're going to add these up. And we get 4. Oops, that should be a 4 there. I can add 44.0 grams. And we're going to put that right there. So there it is. We will now come in here and get our answer. So let me pull up the calculator again. So here's our lovely calculator. We started off with 5.62. Alright, oops. Try it again. 5.62. I'm going to put my E button in here. That means times 10 to the 22nd power divided by 6.02 times 10 to the 23rd. You can multiply by 1 if you really want to. And now we're going to multiply, remember multiply what's on top, multiply by this 44.0 grams. Divide by 1 if you really want to. CP go to 2 decimal places, and it so happens that with our sig figs for honors, it's going to be the same answer. So 4.1, that 7 is going to round that 0 up to a 1, so 4.11. So we go over here, and this is equal to 4.11, and this is molecules cancels out, moles cancels out, we're left with grams of CO2. Sorry, I'm running out of room. So 4.11 grams of CO2. Let's go to another problem. Alright, a penny before 1982 was made of mostly copper. All copper atoms are in the penny, and all copper atoms in the penny. And the penny has a mass. This kind of is worded weird. The penny has a mass of 2.51 grams. How many atoms of copper are present? Okay, this time I'm starting you out with grams. And we're talking about grams of copper. And this time I want to know how many atoms we get in the end. So, I don't want to keep grams of copper. But like we learned from the last video, I can go from grams to moles of copper. And then I can go from the mole of copper to atoms of copper. We got a mole and gram together. Remember, for every 1 mole, it equals the mass from the periodic table for copper. If we go over here and find copper, it's 63.5. So here we go. I'm going to put my 63.5 grams of copper there. And then if you remember, 1 mole is equal to Avogadro's number for atoms, 6.02 times 10 to the 23rd. Pop up my calculator. So here we go. I'm going to do this. We start off with 2.51 grams. You can multiply by 1 if you want, then divide by 63.5. Press enter. And then multiply, for those that are doing the times and not doing the E, that's fine. I'm going to show you. Remember, in parentheses, 6.02 times 10 to the 23rd. Close parentheses and press equals. Alright, for honors and CP, it's going to be the same answer here. 2 and then that 9 rounds the 7 up to an 8, so 2.38. Don't forget about this right here. That means times 10 to the 22nd power. So 2.38 times 10 to the 22nd. So 2.38 times 10 to the 22nd. Grams is gone, moles is gone. We're left with atoms of copper. So atoms of Cu. Last one. we start off with 2.33 grams of NaCl. I don't want to keep grams of NaCl, but I can go to moles of NaCl from there. And then I want to cancel out moles of NaCl. And I go to formula units. Now, real quickly, side note, NaCl, if you remember, that's an ionic compound. How I know is sodium's a metal and chlorine's a nonmetal. And we don't call these molecules, this is a compound, we call them formula units. So remember from the last one, told you it's the only time you can write this or do this. We're going to abbreviate that F.U. Alright, formula units of NaCl. So here we go. 1 mole here, grams. Oh, this is a compound. Now, this is 2 elements, Na for sodium, Cl for chlorine. So let's go back. We find sodium to be 23.0. So sodium is equal to 23.0 grams. There's only 1 sodium since there's no subscript there. And then for chlorine, it's 35.5 grams. So chlorine is 35.5 grams. We are now going to add these up. Alright. And when we do that, we're going to find out it's 58.5 grams. And that's what goes right here. We're now got a mole and formula unit together. 1 mole is equal to 6.02 times 10 to the 23rd. Formula units. Alright, multiply on top, divide on bottom. This time I'm just going to do it in the calculator that's in my hands. So 2.33 divided by 58.5. Then multiply by 6.02 times 10 to the 23rd. Alright, it happens to be the same answer for CP and for honors. Sorry, I ran out of room here, so I'm going to put it here. We have 2. This is equal to 2 points. Sorry, it's going to round to 40. So 2.40 times 10 to the 22nd. 22nd. Wow, that's a horrible 2. So 2.40 times 10 to the 22nd. And that's going to be formula units. And for some reason my thing's not writing anymore. So that's going to be formula units there of NaCl. Sorry about that, it's not writing anymore. Fix that. Alright, so write down your units FU of NaCl because those cancel. So formula units of NaCl. Alright. And that is how we do it. So hopefully you got this. And ask questions in class when you come in if you need them.